Example 1, solving angle side. Use the law of sines to solve the angle side triangle shown. We see that we have two angles, a 40-degree angle, a 60-degree angle, and then we have an angle C. We have a side B, side C, and we have a side length of 4 opposite the 40-degree angle. So first thing we're going to do is find the measure of angle C. So we know that 40 plus 60 equals 100. 180 minus 100 gives me 180. Next, we will find the length of side B. When we fill in the portion of the law of sines, we use the part for the information that we were given. So we were given the 40-degree angle and the 60-degree angle. So when we set up our proportion, we cross multiply. That gives us B times the sine of 40 degrees equals 4 times the sine of 60 degrees. When we divide both sides by the sine of 40 degrees and do the calculation, we find that the measure of side B is about 5.39. Hopefully that makes sense, since the smaller side is 4. So now we'll find the length of side C. So we select the proportion that will allow us to find the length of side C. Go cross multiply. So that gives us C times the sine of 40 degrees is equal to 4 times the sine of 80 degrees. Once we divide both sides by the sine of 40 degrees, that gives us a measure of 6.13. So we do see that the side opposite C, which is the biggest angle, has the greatest length. Example 2. Solving side-side angle. Let A equal 6, B equals 8, and A equal 35 degrees. So here's a triangle where we have satisfied the information given. Notice that this is the two angles at the bottom are acute, and the top angle appears to be slightly obtuse. But here's another version. If instead of having the side of length 6 along the right side, we make it here instead. Now we have a different triangle. Okay, but the triangle still has one side that's 8, the other side 6, and then we have the 35-degree angle. So what we're going to do is do both cases, right? So if I label these vertices A, B, and C, okay, I see that B is equal to 8. All right, so there's my angle B. All right, so I'm going to use this proportion, sine of A over A equals the sine of B over B. Okay, so we have these two triangles. All right, we will start with sine of A, well, sine of A and sine of B. All right, so we set up that proportion. We cross multiply. We have 6 times the sine of B equals 8 times the sine of 35. When we divide both sides by 6, we get the sine of angle B is 8 times the sine of 35 divided by 6. So to find B, we use the inverse sign. That gives us a value where B is approximately 49.9 degrees. All right, now that we know that angle B is 49.9 degrees, that means this angle here is 49.9 degrees. That is this angle here. Now I notice that these two sides, of course, are both 6, so that makes an isosceles triangle. So that means this angle over here is also 49.9 degrees. So with these two angles having the same measure, okay, then that leaves 95.1 for this angle up here, because this right here is 35 degrees. All right, when I add them together, subtract from 180, that gives me 95.1. Now, since I know this is 49.9 and it makes a, since this angle here is 49.9 and it makes a linear pair with this angle over here, all I have to do to find the measure of this angle is to subtract 49.9 from 180. That gives me 130 degrees, 130.1 degrees. So now that I know these two, now that I know these two in the bottom, now to find the angle up here, I simply subtract these two from 180, and that's going to give me 14.9 degrees. Okay, so this angle is 14.9, because I know this is 35, and I know this is 103. I'm sorry, 130.1.
Is somebody saying anything?
Now to find the side lengths for C, I will use these ratios. Example 3, solving side-side angle. Solve the triangle. A equals 2, C equals 1, and the measure of angle C is 50 degrees. So I'm going to start off by drawing a diagram to represent the triangle. So I have a side here, I have a side here. I know this is 50 degrees, so this is going to be C. All right, so I know I have a side A that is 2, so I'm going to put that right here. So that means that, let's say I draw, this is going to be where angle A is. So then my angle So this is C is equal to 1. Okay? All right, so we're going to need to find, so that means this is angle B. So we need to find angle B, and we need to find side B. Well, let's look at the information we have. We have this angle here, C. So I can use the sine of C. I have C and it's 50 degrees. And then I have the 1. Okay. I have A is 2. So basically I need to use the sine of A divided by A and the sine of angle C divided by C. So I'm going to write down the sine of A, which I do not know, divided by A, which is 2, and the sine of angle C, which is 50 degrees, divided by 1. All right, so I need to find what angle A is. So if I cross multiply sine of A times 1, that's just sine of A. And that's going to be equal to 2 times the sine of 50 degrees. I'm going to do something a little bit different. I'm going to actually go ahead and calculate this. And 2 times the sine of 50 degrees would be 1.53. Now, the problem with that is, remember, when we're working with the unit circle, okay, let's say here's my 0, here's 90 degrees, here's 45, so 50 would be like right here. Okay, so this would be like 50 degrees. But we know that the maximum value for sine, which is my y value, can be 1. And I got an answer here for 1.53. So basically that means that there's no angle A where this would be true. So in this case, there is no solution.